Okay, input motor.
Hello, hello.
Good evening, sir.
Okay, input motor.
Just coming, just coming. Give me 2 minutes. Anjali?
Good evening,
अंजलि
sir.
गुड इवनिंग. एक बार देख तो रिया श्रीवास्तव कहाँ है? अंजलि बेटा.
Okay, sir. देख रहे हैं. हाँ, sir, देख रहे हैं.
आ गया बेटा. अंजलि आ गया वो.
Okay, sir.
Okay, Thursday's class is on 2:15, if you remember. Any problem, Siddharth, regarding last day's discussion? Siddharth, any problem regarding last day's discussion?
No, sir.
Priyanshu, anybody of you, any questions regarding last day's discussion? Anybody has got any issues regarding last day's discussion? Nobody has got any issues.
No, sir.
Good. Now, today what we are going to do, we are actually going to venture into a very important concept, which will be, surely you'll be getting some questions from this particular section in your class school tests, right? In your final examination, in your midterm examinations, if they have this particular chapter. And of course, those who plan to give competitive examinations, they will also get questions from this particular section. That is number one. Number two, whatever foundations we are building today, right? These foundations will be required throughout in your inorganic sessions as well as organic sessions. So make it sure that you understand whatever we are going to discuss today, right? And how we are going to start, just a moment, please. So what we are going to do is, we are going to first start today with a structure of methane and then slowly build up the concepts. What we are going to do today is, essentially, we are going to discuss about the concept of hybridization, number one. Number two, finding out the hybridization. Number three, what we are going to do is, we are going to basically work on foundations of VSEPR model, that is valence shell electron pair repulsion model. And then, of course, we are going to look into the shapes and geometries of molecules. Now, this is a key area that what we are going to discuss today. We are going to basically discuss about the key areas today, right? Let me start with the structure of methane. These are the areas that we are going to discuss maybe within for this day and the next day, that is on Thursday. Now, so first of all, we'll try to understand what hybridization is. So I'll just give you a structure of methane first, and then I'll try to understand that how can we explain that particular structure. And while explaining that particular structure, we'll understand what hybridization is all about. Right? And then once we understood about hybridization is all about, we are going to talk about any damn molecule under the planet, in this planet, under the moon or the sun. How to find out the hybridization of that particular molecule. I'm going to basically teach you a trick, which is not easily available in all the books. But anyways, a very simple trick, and you can immediately find out. And once we are done with this, finding out the hybridization, this is going to take some time. We are going to look into the foundations of valence shell electron pair repulsion model. And combining the concept of hybridization, learning the trick of finding out the hybridization, applying the foundations, applying the concepts of this VSEPR, you can basically deduce the shapes and the geometries of molecules. This is what we plan to do today, right? So it's a very, 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 very important topic for chemistry in general, number one, and number two, of course, from your examination perspective. Okay. Now, what I'm going to do first is, I am going to basically draw the geometry or the structure of methane. This is called as methane, right? This is what we call as methane. we are going to basically draw the geometry of this particular structure at the beginning. Right. Now it is a tetrahedral molecule. It's a tetrahedral molecule. Now, everything seems to be so French now because none of you understand anything. I'm going to slowly unfold it. A tetrahedral molecule looks like this. Right, this kind of a structure is called as a tetrahedral. Why it is called as a tetrahedral? Because tetra means 4 and hedral means face. So it has got 4 faces. Similarly, if you say it is octahedral, that means it has got 8. Octa means 8 and hedral means faces. Right? So it will be having 8 faces. But as far as methane is concerned, it is tetrahedral. What does it mean? It means at the center, you have got carbon. Okay, fine. First of all, 4 faces. Where are those 4 faces? This particular face is number 1 face. Right? This is the number 1 phase. You have got this particular phase as first phase. The second phase is this one. The second phase is this one. This is my second phase. My third phase is this one. And behind that, you also have got a phase. So how many phases you are now having in total? You have got 1 phase, 2 phase, 3 phase, and behind it, you have got the 4th phase. Suppose you rotate this, then the back phase will also be coming in this particular direction. So you have got 4 phases out here. So that's why it is called as tetrahedral. Now, how is actually this methane, the structure of methane is all about? Let me just draw it once again. You have got, say, for example, this is the bottom phase. Same thing I've drawn. Now what you're having is the carbon is at the center. This is my carbon. Right? Carbon, that means, is at the center. You have got a triangular base, and from the middle of this triangular base, if you draw a perpendicular, carbon will be between this and this face. Between this top and this, the carbon will be exactly at the middle. Then I've got 4 hydrogens. Where will the 4 hydrogens be located? The 4 hydrogens will be located at the 4 corners. Out here, I've got a hydrogen. Out here, I've got a second hydrogen. Out here, I've got a third hydrogen. And out here, I've got a 4th hydrogen. So, carbon is making 4 bonds. What are those 4 bonds? This is hydrogen. 1 bond is like this. The other bond is like this. The third bond goes like this. And the 4th bond is like this. This is what we call as a tetrahedral structure. Did all of you understand this tetrahedral structure? Yes or no? All of you? All 5 of you?
Yes, sir.
Yes, sir.
Yes, sir.
Inva, there's still 2 remaining. Anjali, yes or no?
Yes, sir.
Siddharth? Siddharth, yes or no? Siddharth, your microphone is off. Okay. I think he's raised his hand. Okay, fine. So these are is a tetrahedral diagram. Now, what's happening out here is this, that all these bonds are of equal length. So I write down the points out here. All these carbon-hydrogen bonds are of equal length. This is the first point. Carbon-hydrogen means out here I've got carbon, out here I've got hydrogen. The distance between the nucleus of carbon and the nucleus of hydrogen is called as the bond length. So the bond lengths of all carbon-hydrogen bonds are of equal length. Number two, all the angles. That means out here I've got a hydrogen, I've got carbon, out here I've got hydrogen. I have got hydrogen out here, I've got carbon out here, I've got hydrogen out here. I've got hydrogen out here, I've got carbon out here, I've got hydrogen out here. So there are 4 angles. One angle is between this, this, and this. This is the angle. The second angle is this. You have got this hydrogen, this carbon, this hydrogen. Second angle. The third angle is this. This hydrogen, this carbon, this hydrogen. Third angle. And the fourth angle is this hydrogen, this carbon, this. So I've got these 4 angles. And what we find out is this, that all the angles, all the bond angles, that is hydrogen, carbon, hydrogen, this is the angle, is equal to 109 degree 28 minutes. I got all these 4 bond angles the same. That means all the bond lengths are also same. All the bond angles are also same. Now, what we are going to do is this. We are going to look into the electronic configuration of carbon and try to find out if at all this structure is possible by knowing the electronic configuration of carbon. Here the central atom is carbon, to which 4 hydrogens are combining. So we'll try to find out from electronic configuration whether there is any space in the electronic configuration of carbon to form 4 carbon-hydrogen bonds or not. Let's go and look, try to understand this. Right. Now, what I'm going to do is this. I'll write out here carbon. And carbon has got 6 electrons. So I can draw this particular electronic configurations like this. It is 1s2, 2s2, 2p2. Now this particular 1s is called as the core electron, core electrons, and the outer shell electrons are called as valence electrons. That is the outer shell electrons. I don't know whether you people are writing or not. The outer shell electrons are called as valence electrons. And all chemical bonds essentially takes place with the help of this particular valence electrons. All chemical reactions takes place only through these valence electrons. Core electrons do not really take any part in bond formation. So what we are going to do is this. We are going to write down the electronic configuration only of the valence shell. Right? So it has got 2 s orbitals and 2s orbitals and 2p orbitals. So let me draw the 2s and 2p. This is my 2s and this is my 2p. 2p has got 3 orbitals. Right? Now 2s2 means this particular shell is filled with carbon electrons. And as far as the p orbitals is concerned, it has got 2 electrons. So according to Hund's rule of maximum multiplicity, I'll be having these 2 electrons in 2 different orbitals. Right? Now, out here, what's happening is this. The carbon, how many electrons does carbon has in its valence shell? 2 plus 2, 4. Right? If you look in this particular structure, that means each of them, that means all of this are essentially nothing but covalent bonds. This is a covalent bond. This is a covalent bond. This is a covalent bond. And this is a covalent bond. Now, whenever we talk about covalent bond, it will naturally mean that you have got 1 electron from carbon, 1 electron from hydrogen, and they are sharing. Right? So each bond has got 2 electrons, and one of the electrons belongs to hydrogen, the other electron belongs to carbon. Similar stories out here. You have got 2 electrons, 1 for carbon and 1 for hydrogen. Similar is the story for this, 1 for carbon and 1 from hydrogen. So carbon has got how many valence electrons now? Look out here. 1, 2, 3, and 4. That's what we said. Carbon has got 4 valence electrons. Done. Right? And carbon is having an octet. 1, 2, 3, 4, 5, 6, 7, 8. So octet rule has been valid. Hydrogen requires a doublet. Each of this hydrogen, comes from itself. The other it takes from carbon. So each one of them is having doublet. So bond formation I can explain based on the rules of octets and doublets. But I'm talking about the shapes. Today my interest is on the shapes, not on whether bond formation is there or not. I have got 2 observations. What are those 2 observations? That all the bond lengths are the same and all the bond angles are also same. These are my 2 observations. And I need to say whether 4 covalent bonds are formed or not, whether it is possible. And if it is possible by some mechanism, will the bond length and the bond angle will also be the same? Can I explain this just through atomic orbitals? That's what I'm trying to do. So look out here. I need to have 4 hydrogen coming out here. And we know that each orbital can have a maximum of 2 electrons. That's the maximum. Each orbital can have a maximum of 2 electrons. So you have got 2 electrons out here. That means no hydrogen can come out here. You have got 1 hydrogen can come out here because this particular carbon has got 1 electron into it. So another electron from hydrogen can come out here. This also has got 1 electron. This is about carbon I'm talking about. So another electron from hydrogen can come out here. And this is empty. In a covalent bond, 1 electron is given by the participating atoms. That means 1 electron has to be given by hydrogen, the other electron has to be given by carbon. But out here, there is no electrons from carbon. So how can actually 4 hydrogen bonds can ever be formed? I can form a maximum of only 2 bonds. So this will not do. And this configuration, if you remember, we said this configuration is the ground state configuration. So with the ground state configuration, we simply cannot explain that there will be 4 bonds in carbon. Forget about the bond angles and the bond lengths. If 4 bonds are not formed, so what's the point in discussing about whether the bond lengths are same or whether the bond lengths are different, whether the bond angles are same or different? No point in asking because there are no 4 bonds. So what shall we do? So what we do next is this: we give a little bit of energy out here into this ground state carbon. And when you give energy to this ground state carbon, what happens is this, that one of the electrons from 2s essentially goes to 2p orbital. That means this particular electron jumps out and comes out here. How you are doing this? By giving a little bit of energy into it. That means you are exciting the ground state carbon. Now, if one of the electrons goes from here to here, right now the electronic configuration will be like this. So this is my 2s. This is my 2px. This is my 2py. This is my 2pz. These are the 3p orbitals. And you have given energy to the ground state to come to this particular state. So you will call this as the excited state. So you have basically make a transition from ground state to excited state. Now, is it possible for you to form 4 hydrogen bonds? Let me see. So 1 hydrogen comes and gives a electron out here to form 1 hydrogen carbon bonds. Remember, this is the carbon ground state, a carbon excited state. This is the electronic configuration of carbon. So 1 hydrogen comes out here and gives an electron out here. 1 bond is formed. The second hydrogen comes out here and gives another electron out here. Second bond is formed. Third hydrogen comes out here, gives an electron out here. The 4th hydrogen comes out here and gives an electron out here. So right now, you could actually explain by going from the ground or making a transition from ground state to excited state, you could actually explain the formation of 4 carbon hydrogen bonds. So you made a transition from ground state to excited state by supplying energy. Whenever you're supplying energy, this electron takes this energy and jumps from the lower 2s energy state to a higher 2pz energy state. Up to this much. Is it clear to all of you? Yes or no? Up to this much.
सर वो लास्ट वाला थोड़ा एक्सप्लेन कर दीजिए ना
कौन सा बेटा?
सर लास्ट वाला जो आप लिखे एनर्जी देंगे फिर मतलब
एक इलेक्ट्रॉन जंप करेंगे ग्राउंड स्टेट से. ये पहले इलेक्ट्रॉन कहां पर थे? हाउ वेयर वाज द इलेक्ट्रॉन? द इलेक्ट्रॉन वाज इन 2s स्टेट.
यस सर
अगर if you give energy, one electron will absorb this energy and jump from here to here.
यस सर
तो अभी क्या हो गया? Now I have got four orbitals. Each one of them is having 1 electron each.
यस सर
So they can accept 4 more electrons from hydrogens, 4 different hydrogens.
यस सर
So right now I've got, this is my carbon electronic configuration. Now I've got 4 hydrogen. So am I not now forming CH4? Yes or no, Anjali?
यस सर यस सर
What about Siddharth, Priyanshu, Riya, Shaw, Riya Srivastav?
Yes, sir.
Yes, sir.
यस सर
Right. Right. Now, if you remember the shapes, of these 4 electrons, 4 orbitals. One is essentially, you have got, say, for example, X, Y, and Z. This is my X, this is my Y, this is my Z. Then my S shell or the X orbital will look like this. This is my X orbital, spherical. As far as P is concerned, if you remember, you have got shapes like this. Suppose this is X, this is my Y direction, this is my Z direction. Then one of the orbital will be along the X direction. You call this as Px. You'll be having one of the orbitals in the Y direction. You'll call this as Py. And the other third one will be in the Z direction. And you'll be calling it as Pz. That means Px orbital is perpendicular to Py orbital, is perpendicular to Pz orbital. All of them are perpendicular to each other. Yes or no? All 5 of you?
यस सर
Yes, sir.
Yes, sir.
Siddharth? Siddharth, yes or no? So, okay. So all 5 of, so all this thing will be perpendicular to each other. Now let's look out here. Now I have got 4 hydrogens, right? Now this is, just remember this, that this is one orbital only. This is just one orbital. It has got 2 lobes, but this essentially is one orbital. So one hydrogen is combining with 2px. One hydrogen is combining with 2px. That means one hydrogen is combining with this one. This is my one hydrogen, right? One hydrogen is combining with 2py. That means this is my 2py. The third hydrogen is combining with 2pz, whatever it is, yeah, xyz. So this was z and this is y. So these 3 carbon hydrogen, so this is my hydrogen. This is my origin. This is where carbon is. This is my hydrogen. This is my hydrogen. So all the bond angles, at least three of the bond angles, that means hydrogen, carbon, hydrogen bonds will be 90 degree each. And there will be three bonds, hydrogen, carbon, hydrogen bonds at 90 degrees. This is 90, this is 90, this is 90, this is 90. And then you have got an s orbital. And when you have got a spherical shape s orbital, then my hydrogen can sit any place it likes. It can sit out here. It can sit out here. Or it can sit out here. Or it can sit out at any of the infinite positions it want to. It can sit in any of these positions. It can sit at any of the positions, only one. It can sit down in any of these positions, right? That means I'll be having three bonds which are of 90 degree each. And I'll be having one bond, one carbon, hydrogen, one bond that is hydrogen, carbon, hydrogen with no fixed angle. Yes or no? All five of you?
Yes, sir.
Yes,
Reassure,
sir.
reassure.
Yes, sir.
Fine. So I have got this according to my atomic orbital. So what was this? This is my atomic orbital. These are also my atomic orbitals. So what I have done is this. I have formed bonds. With atomic orbitals which give me three bonds of 90 degree and one bond with no fixed angle. But unfortunately, our observation is this, that all the bond lengths are of equal length. All the bond angles are 109 degree, 28 minutes. That means whatever we discussed in the last 15 or 20 minutes essentially proved that just by combining atomic orbitals will not explain the experimental observations. So we have to think in a different way. So if you have to think in a different way, people thought and came across this particular concept called as hybridization. Hybrid. So what's the point I'm trying to make? The point I was trying to make out here is this, that we have combined the atomic orbitals to form bonds. This is my bond angles according to the orbital directions. Unfortunately, our experimental observations are this. Therefore, this concept will not do. Something new has to be thought of, and we brought in the concept of hybridization. This is the sequence of the discussion that I had in the last half an hour. Mind it, you are going into a very important topic throughout your class 11th and 12th chemistry. And if somebody wants to pursue his or her life in chemistry, then throughout your life, you're going to require this. So try to understand every single step of what I'm talking. Fine. So we are going to discuss now hybridization. What is hybridization? First of all, just concentrate on the word hybrid. What do you mean by hybrid? Hybrid means essentially a mixture. It's a hybrid seed, a hybrid wheat seed. What does it mean? Essentially, They have mixed two different kinds of seeds, taken all the good qualities of two different seeds, mixed them up genetically, and they basically prepared a seed which can essentially give you higher productivity, will not be affected by insects, will be much more nutritious and tasty, like that. It's a hybrid mixture. So in that particular concept, when we talk about hybridization of orbitals, what is meant is this: we are going to mix up orbitals. We are going to mix up orbitals. That means what? Say I have got a grinding machine. Suppose, say for example, I have got a grinding machine, right? And I have got a blade out here, a rotor out here. I have taken the 2s atomic orbital of carbon, put it out here. I have taken 2px, 2py, and 2pz orbital of the carbon and put all these three out here, mixed all these orbitals, and after mixing, after a certain time, when I understand or when I verify that all of them are getting mixed, I will take, how many orbitals did I mix? 1, 2, 3, 4. I am going to take out from here 4 orbitals now. I am going to take out 4 orbitals now. 1, 2, 3, 4. Now, all of them will be having properties of both s orbitals, because you have got put s character of s orbitals out here. And you have also put the character of p orbital out here. So all these 4 orbitals will now be having both the character of s and p. All of them will be having the same character, will be having similar characters. They will be same in all respects. Mix कर दिया ना, फर्क तो कुछ है नहीं. When you talk individually about s orbitals and p orbitals, they are different. But when you mix them up, and from that mixture you are picking up 4 different orbitals as if you are taking it out, then all of them will be the same. So all these 4 orbitals will be having similar properties and similar energy, and more importantly, similar energy. All these 4 orbitals, and these are 4 orbitals will be called as hybrid orbitals. And how many s you have taken? You have taken 1 s. And mixed with how many p orbitals? 3 p orbitals. 1, 2, 3. So you call this kind of a hybridization as sp3 hybridization. 1s and 3p. So by mixing 4, and what are these orbitals, by the way? What are these orbitals, by the way? These orbitals are nothing but atomic orbitals. How many? 4, 1s and 3p's. So from atomic orbitals, by mixing them up, you have come into 4 hybrid orbitals, which is sp3, 4 hybrid orbitals. All of them having similar properties and similar energy. Is that clear to all of you? Do you understand the concept of hybridization? It's just a concept. There's no validity of this concept, except it explains our experimental observations. That's the only validity. But as this proof is concerned, nobody could find out the proof. Is it clear, all 4 of you, the concept of hybridization?
Yes, sir.
Yes, sir.
Who have answered? The remaining 3 are silent. Riya Shah?
Yes, sir.
Priyanshu,
Yes, sir.
Riya Srivastav.
Yes, sir.
Right. So we have understood the concept of hybridization. Now, fine. So what we have done till right now is, I'm going to come back out here into hybridization. First, let me explain the structure first. Now, so we have understood what hybridization is all about. Right. Now, let me tell you this. Now, that means I have had one s orbital. I had three p orbitals out here. This is my s. This is my 3p orbitals. And what I have done is this. I have mixed all these orbitals together, having the same energy and the same properties. Good. Now, each of these orbitals now had how many electrons? Carbon already had 4 electrons within it. So carbon already had 4 electrons within it. And there are 4 hydrogen. Each one of them is giving 1 electron each. So 4 hybrid orbitals will be now having what? 4 hybrid orbitals will be now having 4 pairs of electrons. In space. Space may have a 3-dimensional space. That means what I'm trying to say is this. I have got, say, for example, the carbon atom out here. Say, for example, I have got the carbon atom out here. This is my carbon atom, say, for example. And across this carbon atom, why I'm taking the carbon atom here? Because you are basically walking with the central atom. You have basically mixed which orbitals? You have basically mixed the orbitals of carbon only. So what we have done is this. I have taken this, this is my, say, for example, a central carbon atom. And this central carbon atom has now got how many pairs of electrons surrounding it? 1, 2, 3, 4. That means I have got 4 pairs of electrons across it. Yes or no? All 4, all 5 of you?
Yes, sir. Yes, sir. Yes, sir.
Priyanshu and Siddharth?
Yes, sir.
Siddharth? Siddharth? So I have got 4 pairs of electrons across it. Right? Now. Will this electron pair is going to repel with this particular electron pair? ये भी negative charge है, ये भी negative charge है. Are they going to repel each other? Yes or no? Are they going to repel? Negative charge, negative charge? Siddharth Dimena said, what about the others? Electron में repulsion होगा क्या नहीं होता है? Hello? Riya Shah? Riya Srivastav? Anjali? Priyanshu?
Yes, sir. Yes, sir.
बोलते क्यों
Yes,
नहीं?
sir.
तो electron में repulsion होगा. There will be
Yes, sir.
repulsion between the electron and electrons.
Yes,
That
sir.
means all these 4 pairs of electrons will try to go to the furthest distance apart in 3-dimensional space to minimize repulsions. Suppose, say for example, I have got this particular room. Say for example, I have got this particular room. Now, I have got, say for example, Siddharth out here. And I have got Priyanshu also in this particular room. Now, Siddharth and Priyanshu hate each other. They don't like at all. They refrain to talk with each other. They even dislike each other's company. So what will they try to do? They will try to go the furthest distance apart from each other. That is the diagonal. Yes or no?
Yes, sir.
Yes, sir.
Same story out here. I have got my carbon atom out here, and I have got 4 pairs of electrons, right? And electrons hate each other. So what will be their natural tendency? To go furthest away from each other, to arrange themselves in each other, to arrange themselves in such a way so as to reduce their repulsions. And when we have got 4 pairs of electrons, it has been shown that the geometry where there is minimum repulsion is tetrahedral. This is mathematically can be shown that when my electron pairs across a central metal atom is arranged in the corners of a tetrahedral, then their repulsion is minimum. And that's why CH4 shape is tetrahedral. And the only way I can explain the shape to be tetrahedral is this. I have now mixed, I am no longer using the pure atomic orbitals, but I am using SPS, mixing S and 3p orbitals, so that all of them have got similar properties and similar energies. That means they don't have got a fixed geometry like they were all perpendicular. It is not like that. They have got same properties, same energies, and they are going to arrange themselves in such a way so as to minimize the electronic repulsions. And mathematically, it was shown that for 4 pairs of electrons, this geometry will give you the minimum repulsion. That is tetrahedral. And the angle between this tetrahedral, whichever atom you take this and this and this angle is 109 degree 28 minutes. Similarly, if you take this angle and this angle, that is hydrogen, carbon, hydrogen, that is also 109 degree 28 minutes. If you take this angle, hydrogen, carbon, hydrogen, same angle. If you take this angle, this is also 109 degree 28 minutes. Therefore, only with the concept of hybridization, right? Only with the concept of hybridization, right? You could actually explain the geometry of methane, the shape of methane. Now tell me, don't be shy, because if you don't understand this, then I think we'll be having problems in future. So please tell me whether all of you have understood this or not. You don't have to hesitate. If you have understood, you have understood. If you did not understand, it's my failure. So you did not. So I should be ashamed. You people should not be. So all of you have understood this or not? Riya Srivastav? Yes or no?
Yes.
Riya Shah?
Yes, sir.
Priyanshu Kumar?
Yes, sir.
Anjali?
सर जो हाइब्रिड सर जो आप करवाए हैं सर, तो आप एग्जांपल और देंगे सर?
बहुत देंगे पूरा। अभी तो पूरा ये बाकी जो दिन रहेंगे ना हम लोग का पूरा एग्जाम्पल ही एग्जाम्पल करेंगे हम लोग। ठीक है?
ओके सर।
ठीक, चलो. Now what I'm going to do is this. I need to talk a little bit about hybridization also. How does the orbitals looks like? ठीक है, थोड़ा बाद में. पहले let me just tell you. चलो. Now, when we talked about sp3 or hybridization, how many orbitals were there? Hybrid orbitals. How many hybrid orbitals were there? We have mixed. If you remember, we have mixed 1s and 3p. And how many hybrid orbitals did we get? 4. That means 4 atomic orbitals, AO, gives you 4 hybrid orbitals, HO. 4 atomic orbitals when mixed gives you 4 hybrid orbitals. And how did you name this? If you remember, 1s, 3p, 1s, 3p, sp3. Right? So, if I now say that I have got sp hybridization, what does it mean? 1s and 1p atomic orbitals are mixing. That means I have got 1s orbital and 1p orbitals that is mixing. That is 1s plus 1p. If that be the case, then the maximum number of electrons that I'll be having is 2 for here, 2 for here. That is 2 pairs of electrons. And Priyanshu and Siddharth will be going very far away from each other because they hate each other. So I have got 2 pairs of electrons, pairs, mind it, not 2, 2 pairs of electrons. Therefore, they are going to go to the furthest distance apart from each other. That means the structure will be, this is, say, for example, the central atom, say, for example, then the structure will be, the 2 atoms will be, or the 2 pairs of electrons will be 180 degree with each other from each other. That means I'll be having 2 electrons out in this particular directions, 2 electrons out in this particular direction. So the bond will be 180 degree each other, and the structure will be linear. Did you understand? Valence shell electron pair repulsion. Valence shell में कितना electron है? 4. How many pairs? 2 pairs. Why I'm considering pairs? Because each covalent bond will be having a pair of electrons. Any bond will be having a pair of electrons. So out of 4 electrons, how many chemical bonds I can form? 2. So this is my one bond and this is my other bond. How many electrons are there in this bond? 2. So I have got 2 pairs of electrons out here. One pair out here and the other pair out here. Priyanshu and Siddharth hate each other furthest distance apart. So the angle between them is 180 degree. Therefore, the bond angle will be 180 degree. Therefore, the structure will be linear. Anjali, yes or no?
Yes, sir.
Priya Srivastav, Riya Shaw, Priyanshu, Siddharth.
Yes, sir.
Yes, sir.
Priyanshu,
Yes, sir.
Siddharth. Fine. Siddharth. I don't know what's happened to him. So this is my SP. Now let's talk about this one. Now what I'm going to do is this, I'm going to give you the shapes, right? These are all geometrical shapes. People have found out that this particular geometry gives you the minimum repulsion. So sp2. So sp2 means how many orbitals? 1s plus 2p. That means how many hybrid orbitals I'm going to take? I've mixed 2 atomic orbitals. Therefore, total number of hybrid orbitals is 3HO. How many maximum electrons I can there will be? How many pairs will be there? 6. There are 2 p's. Each p can have 2. So out here I have got 2, 2, 2. So I've got 3 pairs of electrons. So 3 pairs. What is the geometry that will give minimum repulsion? Now it will be like this. I have got the central atom out here. I'll be having A out here. I'll be having A out here. I'll be having A out here. And if you connect all of them, there will be planar triangle geometry. What will be the angle? 120. 120. All the angles will be 120. If you have got sp3, that means you are mixing 1s plus 3p's, px plus py plus pz. That means 4 atomic orbitals will give you 4 hybrid orbitals. How many pairs of electrons? 1, 2, 3, 4. 4 pairs. What will be the geometry? I'm not drawing this. I have discussed this with methane. Tetrahedral. Angle is 108 degree 109 degree 28 minutes. Geometry is tetrahedral. If you have got sp3d, that means how many orbitals you are now mixing? 1s, 1 number s, plus 3 numbers p, plus 1 number d. So 1, 3, 4, 5. So you are now mixing 5 atomic orbitals. This will give you how many hybrid orbitals? 5 hybrid orbitals. How many maximum number of electrons? Each orbital can have a pair of electrons. So there are 5 pairs. So 5 pairs. What will be the geometry? The geometry will be, there are 5 now. This is the geometry. I have got X out here. 1, 2, 3, 4, 5. You call this particular geometry as triangular bipyramidal. In short, TBP, triangular bipyramidal. What is the angle? These angles will be 120 degree, and this is where, now look at me, look at me, look at my hand. So this is where the triangle base is there. One angle will be in this particular direction, so this will be 90 degree to the base. Another will be on this particular direction, so 90 degree to my base. So out here, 120 degrees. So this will be having 120 degrees with this. This will be having 120 degree with this, and the remaining 2 will be 90 degrees. This is for sp3d. If you have got hybridization sp3d2, how many atomic orbitals you are mixing? 1s plus 3p plus 2d. So 3, 2, 5 and 1, 6. So 6 atomic orbitals you are mixing to give rise to 6 hybrid orbitals. Number of electron pairs is 6. 6 pairs. What is the best geometry? Octahedral. So this is where my A is. And these are the x's, 1x, 2x, 3x, 4x. And you have got 1x at the top and 1 is at the bottom. So this kind of a geometry is called as octahedral geometry. Each of this angle, so look once again at my hand. So this is where the square is. This is where the square is. And you have got This is where the square is, and you have got one particular, the top one 90 degrees to it, and the bottom one 90 degrees to it. This is the base of the square. So all the angles, this one will be 90 because it's 360. So 90s, all the angles will be 90 degree with each other. All the 6 ones. That means XAX will be 90 degree. XAX 90 degree. XAX 90 degree. XAX, all of them will be 90 degree. Yes or no, all of you?
Yes, sir.
All of you?
Yes, sir.
Okay. Now do one thing. All of you kindly refer to your books a little bit so that you see whether you have understood or not. Who has gone actually? Siddharth, I guess. He's having problem with connections. Right. So do just one thing. Just open your respective books where hybridization is there. That is in the that is in the chemical bonding chapter. Just look into it, the VSEPR model, and see whether you have understood or not. I'll give you a couple of minutes. Also, I'll take a break for 2 minutes. So kindly check it out. So right now the time is 8. I'm coming back by 8:02. So that's the maximum time I'm coming back. I'll give you just 2 minutes. Done? Clear? All of you? Anjali?
सर SP2 3 D3 का बताइए ना.
Yeah? कौन सा?
सर SP3 D3 का बताइए ना.
SP3 एक ही काम कर. SP3 D3 is not there in your syllabus. SP3D3. ठीक है? So how many you have got? 1S plus 3P. This is not entirely in your syllabus. I'm doing this. 3P plus 3D. So one number S, 3 number P's, 3 P's and 3 D's. So how many orbitals, atomic orbitals? You have taken 7 atomic. So how many hybrid orbitals you'll get? 7 hybrid orbitals. How many electron pairs? 7 pairs. So what will the structure look like? It will be pentagonal bipyramidal, PBP. So how will the structure look like? This this, this. Pentagon. Why pentagon? 5 faces. 1 face. 2 face. 3rd edge. 4th edge. And the 5th edge. So pentagon. So this is pentagon. Hexagon, which have got 6 edges. So you have got 5 edges out here. So, so out here, you will be having the central atom A out here. And the remaining X, 1X, 2X, 3X, 4X, 5X. And the other X will be 90 degree to each. XX. So 5, 6, 7. So this kind of a geometry is called as pentagonal bipyramidal. In short, PBP. और एक बाइपिरामिडल को करे थे हम लोग. Like this. X. This is A. X, X, X. Out here there was X. The other one out here. This is called as how many edges? 3. Trigonal bipyramidal. What was the hybridization? sp3d. 3, 4, 5. So sp3 is going to give you trigonal bipyramidal. PBP is going to give pentagonal bipyramidal. This is what we have done. Anjali, clear?
सर डिग्री कितना का बनेगा सर? सर डिग्री
This entire angle is 360. हाँ कि ना बता? This entire circle is 360
हाँ सर
divided by 5. So 360 divided by 5 is 72. So each angle will be 72 degrees. And the other two will be 90 degrees. Clear?
यस सर.
What about the others? What about the others? Clear or not? Riya Shah?
यस सर.
Riya Srivastav? Riya Srivastav is not there. Priyanshu? Priyanshu, yes or no?
Yes, sir.
Siddharth? Siddharth has raised his hand. So this is what hybridization is all about. Now, look, and now I'm going to give you the name. Which electrons you have chosen or which orbitals you have chosen for hybridization? The valence shells, the valence electrons. That is the valence shell. So out here, you have chosen those orbitals to make a mixture about is the valence shell. Right? How many electrons did you consider? How many electrons did you consider? You consider pairs of electrons. So pairs. How did you come into this particular geometry? Repulsion. So coming to this kind of a shapes with their angles and the bond angles essentially can be called as valence shell electron pair valence shell. We have talked only about the valence shells. We did not discuss about the core shells. So valence shell electron pair repulsion theory. So V S valence का V shell का S EP electron pair repulsion. So this is called as VSEPR theory. Yes or no, all of you?
Yes, sir.
Yes, sir.
All of you? प्रियांशु क्या हुआ है? तू आज चुपचाप है? या तो बहुत
Yes,
क्वेश्चंस
sir.
रहता है, आज पूरा चुपचाप है, क्या हो गया? तबीयत ठीक है?
Yes, sir.
अंजलि क्लियर?
हाँ सर.
ठीक ठीक चल. Now what I'm going to teach you. So what I've done till now, let me just summarize. बहुत कुछ पढ़ाया दिया आज. These are all very interesting concepts. I try to basically make clear in minimum words as possible. Right? हम लोग अभी तक क्या किया? We talked about hybridization and how hybridization came into picture by taking the case of methane. Right? We have talked about the foundations of VSCPR. We have understood jitna pair of electrons रहेंगे, that is basically going to talk about the geometries. Shapes we did not talk as of now. Shapes of molecules we did not talk about. We talked about the geometries of the electron pairs till now. Agar there will be two pairs, it will be linear. Agar there will be three pairs, so it will be trigonal planar. If there is four pairs, it will be tetrahedral. If there is five pairs, it will be trigonal bipyramidal. If there are six pairs, that will be octahedral. If there is seventh pair, that is not in your syllabus, theoretically speaking, it will be pentagonal bipyramidal. Angles, yes. Right? We have done all, and bond angles will always be the same. Up till now, whatever we have discussed till now, we'll see variations about it, but till now, that is what we have talked about. Right? Now, what I'm going to teach right now is a trick that whenever a particular molecule is given, how do you find out the hybridization? And once you're finding out the hybridization, if you find out, say, for example, sir, it is sp2 hybridization. Oh, sp2 beta, then it has to be planar triangle. All the bond angles are known. Sir, I have found out the hybridization to be sp3. Oh, you have found out sp3d. Fine. It will be trigonal bipyramidal. And the bond angles will be this. इतना ही simple सा matter है. बच्चा यहाँ पर पूरा गड़बड़ कर देता है. They think it's very difficult. It's actually very easy, provided you know the trick, provided you know how to find out the hybridization. So what I'm going to do next is, I'm going to explain you how to find out the hybridization. This is not a theory, this is a trick. So whenever you're talking about a trick, don't ask me about the justification of the trick. Trick has got no justifications. It's a simple way to do things by remembering a few simple steps. Right? So what I'm going to do right now is, I am going to basically teach you the trick of finding out hybridization. So what I'm going to do next is trick to find out hybridization of molecules. एक तो examples मैं करा देते हैं, then I'm going to give you, as Anjali has ordered me to do, both are examples. Now, if I explain you 2-3 examples, you can do it yourself. इतना ही simple सा मामला है. हम लोग का पता नहीं होता है, that's why we get basically confused. ये बहुत difficult है. Difficult है ही नहीं. देख. Let me talk about the hybridization of, say, BeH2. Right, let me talk about the hybridization of this. What I'm going to do is this. As far as hydrogen is concerned, we are going to take hydrogen has got 7 valence electrons. We are going to assume this. आप तो बोलेंगे sir, hydrogen has got only 1 electron, valence electrons. How can you take 7? अरे भैया, I already told you this is a trick. Don't try to give a justification for it. I'm just explaining you how things can be done. How to do it without even understanding any theory. Without even trying to say, sir, ये तो पूरा गड़बड़ है. हाँ, गड़बड़ तो है. I also know it. How can hydrogen have 7 valence electrons? But we are assuming that hydrogen have got 7 valence electrons. इससे हम लोग का काम बन जाता है. चलो, let's do. Now, beryllium. How many valence electron does beryllium has? It is in the second period and the second group. So if it is the second group, there will be 2 valence electrons out here. So what we are doing out here is calculating the number of valence electrons. So what you are doing out here is, just a moment. What you are doing out here is, you are calculating the number of valence electrons out here. So beryllium has got 2 valence electrons, right? Each hydrogen has got 7 valence electrons. So there are 2 hydrogens. So 14. That means 16. So the first step is what? The first step is calculate the number of valence electrons. Just remember this. Then hydrogen has got 7 valence electrons. So this was my first step. So I've done the first step out here. The second step, divide by 2. Divide the number of valence electrons by 8. Right? So 16 divided by 8. It is directly divisible by 8. So this will be 2 bond pairs are there. Bond pairs are there. This is, I'll write it down. Let me write it down. You will not find any books. 2 bond pairs are there. So if it is exactly divisible, then there will be 2 bond pairs. Suppose you had 18 divided 18. Suppose the total number of valence electrons in some other cases be 18. You are going to divide it by 8. One which is directly divisible 8. So you are going to basically divide it by 18. So you'll be getting 2. And the remainder will be 2. This is my remainder. If we divide 18 by 8, so 2 will go, 8 to the 16, and 2 will be remainder. This 2 will be my bond pairs. And this 2 will be my unpaired electrons. So 2 electrons will give you how many? 1 lone pair electrons. Lone pair means one which is not taking part in bonds. So this is lone pair electrons. Similarly, suppose you have got a total number of valence electron is 20. You are dividing by 8. Right? So out here, direct division is 2. So I have got 2 bond pairs of electrons. The remainder is 4. So plus 2 lone pairs. This is how we do things. Right? Now, this bond pair and lone pair gives you the hybridization. So out here, I've got 2 bond pairs plus 0 lone pairs. Because it's exactly divided. So I've got 2 bond pairs. That means this will be sp hybridized. 2 bond pairs. It will require 2 orbitals. S and p. One s and one p is mixing. 2 atomic orbitals mixing gives you 2 hybrid orbitals. So those hybrid orbitals are called as sp hybridized orbitals. So I've got 2 sp hybridized orbitals. Each orbital, hybridized orbital, is having 1 pair of electron. Priyanshu and Siddharth are hating each other, maximum distance apart. So sp hybridized shape is linear. So this will be linear. Means 180 degree. That means I'll be having what? I'll be having my BE out here, hydrogen out here, hydrogen out here, and this angle will be 180 degree. That means hydrogen, beryllium, hydrogen angle is 180 degree. Done. You have found out the hybridization, you have found out the shape, you have found out the bond angle. और क्या चाहिए? 1 second में काम खत्म. Just taken 1 minute. Okay, let's do. बहुत ज्यादा थियोरी बताया मैंने, इतना जरूरी था ही नहीं. But yes, it is required for understanding. Suppose now I take CH4. Suppose CH4. Number of valence electron as far as carbon is concerned, it is in the 4th group. So 4. Hydrogen I've taken 7. So 7 into 4, 28 plus 28. Total mix 32. Divide by 8, second step. So I've got 4 bond pairs plus 0 lone pairs. That means I've got 4 bond pairs. That means this will be sp3 hybridized, 4 p3, and 1 is 4 sp3 hybrid orbitals is required to accommodate 4 bond pairs. So what's the angle? So what should be the angle? The angle should be, check it out. Check it out. 109 degree, 28 minutes tetrahedral. हो गया मेरा geometry. 109 degree, 28 minutes tetrahedral. Simple. Is that simple? Is that simple? But yeah, this has got one particular problem. You can apply this particular trick only for even number of electrons. When the molecules have even number of electrons. Say for example, I have got NO2 minus. Nitrogen have got 5 valence electrons. This is in the 5th group. Each oxygen has got 6 valence electrons. I've got 2 oxygens, so 12. I have got 1 electron extra plus 1 electron. That is 1. So 5, 12 by 5 is 17. 17 plus 1, 18. So total number of valence electron is 18. Even, because this rule is only applicable for even number of electrons. So divided by 8. So I've got 2 bond pairs directly divisible. Remainder is 2 electrons. That is going to constitute 1 lone pair. That means I have to accommodate 3 pairs of electrons. 2 of them are bond pairs and 1 of them is lone pair. I need to accommodate 6 electrons. That means I'll be requiring 3 orbitals. That means this will be sp2. S1 and 2p's, 3 atomic orbitals are mixed to give you 3 hybrid orbitals. And what should be the bond angle? Or what should be the geometry? sp2, planar triangle. That means how will the structure look like? The structure is going to look like this. Nitrogen, the central atom, oxygen, oxygen, oxygen. Each angle is 120 degree. काम खत्म. Tell me, Did all of you understand this? Did you know about this? Or this is a very simple way of doing things? Priyanshu? Priyanshu,
Yes, sir.
did you understand?
Sir.
Anjali?
सर हाइड्रोजन का सिर्फ 7 ही बैलेंस इलेक्ट्रॉन्स रहेगा सर हमेशा सर तो फिर
हाइड्रोजन
मतलब सर अगर
अरे सुन, हाइड्रोजन का बैलेंस इलेक्ट्रॉन कितना होता है?
सर आप ही तो बोले मानने के लिए कि 7
हाँ, लेकिन होता कितना है? एक ही होता है ना?
सर एक होता है
हाँ, but in this, for this trick we are going to assume there are 7 electrons only for the case of hydrogen. बाकी जिसको जो है वो इसी पकड़ना है.
सर मतलब जैसे हाइड्रोजन के लिए हमने एक लिया तो और जो बाकी है हम उसके लिए सेम लेंगे जितने में उनकी लास्ट सेल में इलेक्ट्रॉन है.
हाँ?
सर जैसे केवल सर ये हाइड्रोजन के लिए क्यों है सर ऐसा रूल?
It's a trick बेटा, trick का कोई तो rules नहीं होता है. It's just a way
ओके
that
सर.
we do things.
ओके ठीक है. ओके सर.
Reassured, did you understand?
यस सर
एकदम simple है ना?
हाँ
People get confused about this. Siddharth, I've understood this. Priyanshu questions पूछ लिया. अंजलि, रिया श्रीवास्तव तो कहाँ चला गया क्या पता?
सर एक बार एक और मतलब करके दिखा दो फिर मतलब
वो
और clear हो
दिखाएंगे.
जाएगा.
वो आज और next today and next day.
ओके सर.
All will be devoted on this only. एकदम सिंपल है ना प्रियांशु?
हाँ सर.
कर ले. वाटर कर, एमोनिया कर ले, कोई बात ही है नहीं.
फिर दोबारा से हाइड्रोजन में 7 लेंगे.
14 plus 6.
14 यस सर. 14 plus 6
20 divided by 8.
यस सर. जाएगा 10 4
2 bond pairs.
2.5 यस सर. हाँ सर 2.5.
2.5 नहीं.
हाँ सर वो समझ गया मैंने. ठीक है ठीक है.
2 bond pairs and 4 remainder electrons. That means 2 lone pairs.
यस सर.
That means how many electrons I need to accommodate? 4 pairs. That means this has to be sp3 hybridized.
यस सर.
I require 4 hybrid orbitals sp3. That means
Yes, sir.
what is the angle? So my geometry will be like this. Shape को बारे में I'm going to talk next day. आज तो कल hybridization सिखा रहा है तुझे. So out here sp3. That means out here what I have got? My oxygen is out here. This is my oxygen. This is my hydrogen. This is my hydrogen. 2 lone pairs. So this will be my bond. So I've got 2 hydrogens out here. The angle, इसका angle को बारे में change होगा. I'm just teaching today the fundamentals. 109 degree 28 minutes होना चाहिए, होगा नहीं. ये कम हो जाता है. This becomes around 104 degrees. वो किस लिए होता है next day? एकदम सिंपल, कुछ है ही नहीं. अमोनिया कर. 5 is the valence electrons. 21, 26 divided by 8, 3 bond pairs plus 2 remainders. One lone pair, sp3. So once again, this will be the structure. This will be my nitrogen, hydrogen, 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 and here will be the lone pair. This is the structure. 1 second. It will not take more than 1 second. It will not take more than 1 second. खतरनाक चीज है ये. बच्चे को कोई ज्यादा बच्चे को पता ही नहीं है. That's why they get so worried about this particular chapter. But it is so simple, so simple, so simple. ले last example आज का लिए. और एक करा देते हैं. खतरनाक example दे रहे हैं. HCOF2. अगर एग्जाम में ये स्ट्रक्चर आपको देते थे, सपोज यू आर नॉट अटेंडिंग दिस पर्टिकुलर डिस्कशन, इफ यू आर नॉट अ पार्ट ऑफ दिस डिस्कशंस, आप लोग को तो दिमाग खराब हो जाते थे। केसी करेंगे सर, जेनॉन दे दिया, ऑक्सीजन दे दिया, क्लोरीन दे दिया, तो मर जाएंगे सर लोग। मरने को बात है ही नहीं बेटा। XC मीन्स नोबल गैस, 8th ग्रुप, 8 वैलेंस इलेक्ट्रॉन। ऑक्सीजन 6 पीरियड, 6 वैलेंस इलेक्ट्रॉन, 6। फ्लोरीन 7 valence, 7th period, 7th group, 7 valence electrons, 14. 28 divided by 8, 3 bond pairs, 24, plus 4 remainder, 4 electrons remainder, 2 lone pairs. That means 3, 2, 5, I have to accommodate 5 pairs of electrons. I require 5 orbitals, sp3d. sp3 क्या होता है? Triangular bipyramidal. That means theoretically, इसको बारे में हम लोग बहुत बात करेंगे next day and maybe also the next day also. Look, central is Xe. I have got O out here. I have got F out here. I have got F out here. This is one my lone pair. दो lone pair है ना मेरा? A rough estimation. All these structures will modify once we know the next step. But this is the first cut. Hybridization तो निकाल ली. But whether the lone pair will be here or here, उसको बारे में तो we are going to talk in the next day. That is going to take another big discussion. But this will be the structure. What will be the angle? अरे भाई इसको बीच में तो मेरा 120 डिग्री होगा, ये लोन पेयर है इसको बीच में तो 90 डिग्री होगा। खत्म, सब कुछ एक साथ में फटाक करके आ जाता है। एक एनी एग्जांपल, एनी डैम एग्जांपल, एक स्ट्रक्चर बताना। ले और एक ले, कार्बन डाइऑक्साइड। Carbon is the 4th period, the 4th group, 4 valence electron. Oxygen is in the 6th group, 6 valence electrons, 2 है, 12, 16, 8, 2 bond pairs. Carbon, oxygen, oxygen, sp hybrid, 2 bond pair है ना, sp hybridization. Okay, linear. 180. फटा फटा, just like that. It happens just like that. इतना ही सिंपल। ज्यादा ज्यादा बच्चे को, दोस्त को पूछ, go and ask your friends, स्ट्रक्चर लेके जा, रो देंगे। किसी को पता ही नहीं है। Nobody knows about this except the people who study for JEE. These tricks are available only for them. Siddharth beta, clear? Very good. Riya Shah?
Yes, sir.
Absolutely clear beta?
हाँ sir.
Yangshu?
Yes, sir.
अंजलि बेटा?
सर रिसोनेंस क्या होता है?
रेजोनेंस के बारे में हम लोग बहुत सारा बात की थी ना बॉन्डिंग के टाइम में ना, नहीं किया? नहीं किया ना? लास्ट क्लास में किया था रेजोनेंस? आई डोंट रिमेम्बर।
सर आपने कहा था पढ़ के आने के लिए बॉन्ड लेंथ, फिर से बॉन्ड एंगल।
हाँ ठीक है, नेक्स्ट डे करा देंगे, ये करेंगे और वो करा देंगे, ठीक है?
ओके सर।
अच्छा, नेक्स्ट डे द क्लास स्टार्ट्स एट 2:15। टेल रिया श्रीवास्तव, अंजलि रिया श्रीवास्तव को बता देना, तो भाग गया यहाँ पर, कहाँ चला गया क्या पता।
ओके सर।
अगर वो नहीं क्लास करेंगे तो हम लोग 2:30 में स्टार्ट करेंगे, लेकिन अदरवाइज इज 2:15, ठीक है? रिया, अंजलि, टेल रिया श्रीवास्तव। चल बाय।
थैंक यू सर।
बाय सर।
गुड नाइट सर।
प्रियांशु भी चला गया, चल।